PALEOQUEST podcast, unraveling the mysteries of paleosciences, making the past easy to understand and exciting to explore. Today, we're on a bit of a treasure hunt. Present-day rivers, they hold a key to unlocking these energy resources. Okay, so we're basically looking at modern rivers to understand what happened millions of years ago. Our source material for this deep dive is, it's a field training program guide.
Oh, cool.
It's focused on the Narmada Valley in India.
Oh, the Narmada Valley. Yeah, I know it. It's a fascinating region. It's led by Dr. Pravin Sukumaran.
So how do we actually connect the dots between modern rivers and these ancient oil and gas deposits?
Well, it all comes down to understanding fluvial systems. Essentially, we need to know how sediments are deposited, eroded, and transported by rivers. You know, think of it like this. Imagine a river carrying sand and gravel downstream. Over time, those sediments, they settle in different patterns, depending on the river's flow, the surrounding landscape, and a whole host of other factors.
So it's like the river's painting a picture with sediment, and we're trying to decipher the message millions of years later.
Exactly. And those messages, they're crucial for predicting where oil and gas might be trapped underground. For instance, a fast-flowing river might deposit coarse sand and gravel, and then, a slower meandering river that might leave behind finer silts and clays. Each of these deposits has different properties that affect how fluids flow through them.
Okay, so different types of sediments create different environments underground. But how do we know which ones are likely to trap oil and gas?
By studying how sediments are being deposited in present-day rivers, we can get a better picture of what those ancient reservoir rocks might look like.
So it's like using a modern-day river as a time machine to peek into the past.
Precisely. And the Narmada Valley, it's a perfect example of this. It showcases a variety of ancient and modern river features, so it provides a unique opportunity to connect those dots between the past and present.
Okay, I'm starting to see how this all fits together, but I imagine studying these underground layers, it must be a pretty complex process. How do researchers actually see what's going on down there?
Researchers use a variety of techniques, including geophysical surveys to map the subsurface. One fascinating method, it's called microtremor profiling, which, essentially uses ambient noise, the subtle vibrations that are always present in the earth. And it uses that to create images of the different layers of rock beneath the surface.
So it's like listening to the Earth's heartbeat to understand its inner structure. But let's get back to the Narmada Valley for a moment. What makes it such a great place to study these ancient river systems?
Well, for one thing, it has a diverse range of rock formations, from very old Precambrian rocks to much younger Quaternary deposits. By understanding the history of the Narmada River and how it's deposited sediments over time, researchers can identify specific locations where those reservoir rocks, those potential traps for oil and gas, they're more likely to be found.
So it's like using the river's history as a guide to pinpoint the most promising spots for exploration. Where do we go from here in this deep dive?
Yeah, one specific site researchers have been focusing on is called Uchadia.
Uchadia. What's so special about that location?
It's like preserving a detailed record of the Narmada River's activity over the past few thousand years. Researchers been analyzing sediment layers.
Okay, so we're zooming in on this specific site to understand how the river behaved in the past. What kind of information have they been able to glean from these sediment layers?
Well, one of the most striking discoveries is the presence of rhythmic sediment cycles. These are repeating patterns of different sediment types that indicate periods of flooding, followed by periods of relative stability.
Rhythmic sediment cycles. Can you paint a picture of what that might look like?
Sure. Imagine a powerful monsoon season causing the river to swell, carrying a surge of water and sediment downstream. This would leave behind a distinct layer of coarser materials like sand and gravel. Then, as the floodwaters recede, finer sediments like silt and clay would settle out, creating a contrast in layer. Over time, these cycles repeat, creating the layered record of the river's activity, almost like a fingerprint.
That's pretty incredible. But how does knowing about these ancient floods help us in our quest for oil and gas?
Understanding these flood cycles helps us identify the specific types of sediments that were deposited during those events, giving us clues about where those reservoir rocks might be located. But the story gets even more interesting. Researchers have also found evidence of ancient storm events preserved in these sediment layers at Uchadia.
storms.
Yeah.
So we're not just talking about regular monsoon floods, but, major weather events that left their mark on the landscape.
That's right. These storm deposits, often characterized by distinct layers, of course, sediment and shell fragments. They indicate periods of intense wave action and coastal erosion, likely caused by cyclones making landfall and, sending powerful surges inland.
Wow, that sounds intense. How do researchers distinguish between these storm deposits and the regular flood deposits we were talking about earlier?
It's like being a geological detective. Researchers use various clues, including the size and type of sediment grains, the presence of marine fossils, and the overall structure of the deposits. Storm deposits often show signs of rapid deposition and high energy transport, whereas flood deposits tend to be, more gradual and show evidence of sorting by flowing water. These storm deposits, while less common than flood deposits, they add another layer of complexity to our understanding of the Narmada Valley's sedimentary history. By identifying these events, researchers can build a more complete picture of the types of sediments that were deposited in different environments over time. And by understanding these past events, we can also start to anticipate how future changes, like climate change and sea level rise, might impact river systems and the formation of potential hydrocarbon reservoirs.
But before we go too far, I want to make sure we understand how researchers actually decipher all of this information hidden in the rocks.
Researchers use a variety of techniques, but one of the most powerful is called multi-proxy analysis. This involves combining different types of data, like grain size, magnetic properties, and even microfossils, all to build a more comprehensive understanding of the past. And by piecing together all of these different pieces of evidence, researchers can create a detailed picture of the Narmada Valley's environmental history.
This is truly remarkable work. It seems like every feature of these ancient river systems has a story to tell, a clue to offer about the potential for finding valuable resources.
You're absolutely right. And by piecing together these clues, like detectives at a crime scene, we can build a more complete picture of the subsurface and guide exploration efforts with greater precision.
But finding the right clues is just the first step, right?
Yeah.
We still need to understand how those clues relate to the actual formation of oil and gas deposits. How does understanding these rhythmic sediment cycles, storm deposits, and the overall dynamics of fluvial systems help us pinpoint the locations of those deposits?
That's where our understanding of sedimentary facies comes into play. Remember how we discussed that different types of sediments form under specific environmental conditions? Well, those same principles apply when we're looking for oil and gas.
So it's not just about finding sandstone. It's about finding the right kind of sandstone. The kind that...
You got it. By understanding the processes that shaped these ancient river systems, we can identify the types of deposits that are most likely to host those valuable resources.
Okay, so what are some examples of these prime real estate deposits that oil and gas explorers are looking for?
One example is point bars. These are crescent-shaped deposits that form on the inside bends of meandering rivers. As the river curves, it erodes the outer bank and deposits sediment on the inner bank, creating these point bars. These deposits often consist of well-sorted sand, which can be an excellent reservoir rock.
So if you're looking for oil and gas, those point bars are like giant X marks the spot signs. But why is well-sorted sand so important? I imagine not all sand is created equal in the world of hydrocarbon exploration.
You're right about that. Well-sorted sand is important because it creates those interconnected spaces or pores within the rock that can hold fluids like oil and gas. And if those pores are well connected, meaning fluids can easily flow through them, then the rock has good permeability, which is, essential for extracting those resources.
So it's not enough to just find a rock that can hold oil and gas. It needs to be able to let those fluids flow freely so we can access them. That makes perfect sense.
Exactly. And that's why understanding the depositional environment of a rock is so crucial. Point bars with their well-sorted sand deposits are just one example of a fluvial facies that can be a promising target for oil and gas exploration.
Are there any other examples of these promising targets that we should be on the lookout for?
Absolutely. Other prime targets include channel sandstones, which are essentially the remnants of ancient river channels, and levee deposits, which form along the banks of rivers during floods.
Also plays a role in making it such a promising area for exploration, right?
You're spot on. Remember how we mentioned earlier that the Narmada Valley sits on the edge of the Cambay Basin, a known oil-producing region? Well, that's not a coincidence. The broader geological setting is crucial for understanding the potential for hydrocarbon accumulation.
You have the right types of sedimentary deposits formed in the right environments within a regional geological setting that's conducive to trapping hydrocarbons. It's like hitting the jackpot.
It's a great way to put it, and this is what makes the Narmada Valley such a fascinating case study. It provides a glimpse into the interplay of all these different factors, and it highlights the importance of taking a holistic approach to oil and gas exploration.
It's not just about drilling holes, it's about understanding the entire system, the history, the processes, and the regional context.
Exactly. And this is why understanding fluvial systems, those ancient river networks that have shaped our planet for millions of years, is so crucial for unlocking the energy resources of the future.
So the next time you see a river, remember, it's not just water flowing by. It's a dynamic force of nature, a sculptor of landscapes, and a keeper of secrets that can help us navigate the challenges of the present and the future.
And as we continue our quest for knowledge and a deeper understanding of our planet, the lessons we learn from these ancient rivers will undoubtedly guide us towards a more sustainable and resilient future.
Thank you for joining us on this deep dive. Until next time, keep seeking knowledge, asking questions, and exploring the wonders of the world around us.